In number 34, it says the sum of two numbers, x and y, is more than 8. The sum of two numbers is more than 8. When you double x and add it to y, the sum is less than 14. So what we have here is a system of inequalities. X plus y is greater than 8. If I subtract x from this side over to this side, you should have y is greater than negative x plus 8. If I subtract 2x to the other side, I get y is less than negative 2x plus 14. Now what I'm going to do is graph this. So 1, 2, 3, 4, 5, 6, 7, 8. Graphing the first inequality, the slope is negative 1, so I go down 1 over 1, down 1 over 1. I know the slope was negative 1, so going down 1 over 1. Both these lines are going to be dashed because of the greater than and less than symbol. So part of my freehand here. Y is greater than, so that means we're going to shade above this line. That means all of these points are a solution to that inequality. Okay, now same thing. I'm going to go up to 14, 9, 10, 11, 12, 13, 14. And I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. Same thing where I do a dashed line. This says less than, so what I'm going to do is I am going to shade below. When you have two inequalities on one graph, it's important to label at least one of them. This is 2x plus y is less than 14. And this line was x plus y, or should I say, boundary line. Kai says that the point 6, 2 is a solution to this system. Determine if he is correct and explain your reasoning. Now, if these were the intersection of two lines, yes, it would be the solution. But since this point lies on both dotted lines, it's not going to be a solution. I'm going to demonstrate with some algebra. So what I'm going to do is I am going to plug in 6, 2 into both of these inequalities. So 6 for x, 2 for y. We need to see, is 8 greater than 8? That is not true. It's equal. It's not greater than. Same thing here. 2 times 6 plus 2 is less than 14. You get 12 plus 2 is 14 less than 14. No, that's false. They are equal. So although a point on both boundary lines, although a point lies on both boundary lines, it does not satisfy either inequality. Therefore, it's not a solution. And number 35, we're talking about an airplane going up, flying at a certain amount of miles per minute. They want you to determine the average speed. Now remember, speed is like an average rate of change. An average rate of change means slope. So what I'm going to do is simply find the slope. His vertical distance changed from 762 to 192, or excuse me, 192 to 762, so we're going to go backwards to find the difference, and then there was a difference in minutes of 92 from 32. So I get 570 over 60, and this comes out to about 95 miles per minute. I want you to write an equation in terms of y and x. So since 9.5 is our slope, we're going to say 9.5x. Assuming that the plane maintains its speed at a cruising altitude, determine the total number of miles the plane has flown 2 hours into the flight. Now remember, x is minutes. So what we have to do is say 9.5, and now there are 120 minutes in 2 hours. Now if you put in 2 here, you would lose 1 point, but to get full credit, 120 is your better bet. 9.5. So the key part of this problem is talking about this cruising altitude. Now remember, 2 hours into the flight, so there's our 120, but we have to consider that, it took you 32 minutes to get to that cruising altitude. So what you're really doing is saying 120 minus 32. So 120 minus 32 gives us 88. 9.5 times 88 is 836 miles. But we have to add on the number of miles that it has flown after those 32 minutes.